So now we are live. I would like to welcome everybody to our today's webinar with Open-E JovianDSS Up30. We call it a game-changing update. I would like to introduce myself. My name is Sebastian Reich. I'm a business development manager at Open-E for nearly 6.5 years. And today I'm gonna showcasing you what this update brings and gonna highlight some of the features. And therefore I would like to start with our today's agenda. So we're gonna take a quick look here about us. So first we're gonna say some words about us. As some people don't know about Open-E, I will tell something here. The next point is we're gonna talk about why your system should stay updated, even when the storage runs good right now, or even when it runs flawlessly. Because many people say never touch a running system, but in this case, we're gonna showcase something what is really important here. The next point will be Open-E JovianDSS update version overview. So we have one of the main big features here. The one is called ZFS Special Devices, which we added here. And the other one is NVMe Partitioning, where we're gonna highlight this as well. We will showcase this today in a live demo, even with a live demo environment, even cluster ready. And also gonna highlight what else is new, because we got also some smaller feature sets like Active Directory features and also self-encrypting disk feature updates. And as well, we got some macOS Time Machine support added for all the Mac users here, which were waiting for this. And the next, we will see what's coming next, and we're gonna start a vote and survey. This comes later on. This will be posted later on in the chat. And then, as this is a really frequent topic right now, as we already had the DSS v7 end of life announcement, it's not yet end of life, but there's a lot of question, of course, raised from all our people, all the community, and of course, all our customers. And we're gonna answer this in the Q&A session later on. So let's start with about us. I will tell you something about myself even and about Open-E, what we're gonna doing, and therefore we're gonna change to the next slide. So Open-E is a software development company which consists around 55 people, and we are officially American company. A lot of people don't know that, but it is the official way, but we have also, of course, many offices here in Germany, where I'm located in Munich, as well in Poland, and as well in Japan, because we have also big customers there. This team consists, of course, like all the programmers, testers, UX experts, marketing, and of course, salespeople. We also have content creators, which are also designing the GUI and everything around it. We believe that people are the most important resource here. As you can even see in this picture, this was one of the team building events we had in the last year. I was joining there as well. It was a really nice and pleasure experience, and I really enjoyed it. So a lot of people think we are American, but I feel like that's not true. We are really European company, because everything is based mostly in Poland and even here in Munich. To show you this map here, this is where all our offices are, and we are very proud to say that we have done over 40,000 installations worldwide with Open-E products. This is, of course, like with the previous versions, like with DSS v6, v7, and of course our flagship ZFS product, JovianDSS. So we are in around 100 countries around the world. As already said, we are more than 25 years on the market, which is, I think, remarkable here, because I have seen in my career a lot of companies which were like, of course, getting bankrupt or disrupted, and we're still here on stage, and I think this is pretty good. What is really special with us, we are not selling directly to our customers. We believe that our strategy is we work only exclusively with our partners, and of course with our tech marters as well, where we're always focusing on, let's say, testing new hard drive, testing new SSDs, NVMEs, of course, motherboards, and so on. If you have questions to this later on, you can also ask us here about it. Good, then we are coming to the point why you should update your storage when it runs even good. This is a lot of People think that it is not necessary often, but we believe it is necessary, and I'm going to tell you exactly why. So maybe you have seen in the past there were some, let's say, exploits happening. Maybe you remember some of them. There was this log4j shell exploit. We also, by the way, released blog articles about all them. And there was also this WannaCry ransomware attack. We also did a previous webinar. So if you're interested in this, please feel free to join also our YouTube channel where you can find all these webinars. There are some others as well, but we believe that all these, say, major attacks are the reason why you should update it, because there is some exploit happening in this time, and then everybody has to check the software. Am I affected? Is my company affected? And is this really important for me? And we believe yes, and we say that's why you should always update it. So stay updated is why I already said we have security risks. So we're gonna ask like a Pneumonia Institute survey, and according to it, like almost 60% of the data security breaches were suffered by organization happened because of lack of system updates. So people were missing to update it in time, and yeah, this was of course not nice. And every organization without the breaches rated their patching ability 40% higher than breached ones. This was according to the survey. I'm not so into it, but I believe what they say. As well, we had vulnerabilities, as already mentioned. We had all these cyber attacks, these ransomware attacks. So we had security flaws, even unauthorized access. So the question is mostly not when did we get attacked? The question is like, how did we get attacked? And yeah. We should also stay updated because there were software failures in the system. Without any updates, the stuff comes not working again. Also, we have integration challenges. So I will maybe make a quick example here. You may be using an Android smartphone. You always need to have the latest Android security updates. You always have the latest Android version, that just in order to make your apps work flawlessly and secure, of course. And last but not least, you have, of course, the employee satisfaction, because if there's something happening, like if your software or your apps are not working, you cannot work here, so your production is lowered by a tremendous amount. Yeah, I'm gonna come to the Open-E JovianDSS Update 30 overview, and we're gonna starting with the ZFS Special Devices. So first, I want to showcase or say what we are focused in this update. The main thing we focusing was once was performance, was reliability, safety, and of course it should be cost efficient. So because whenever an update is released, or in general a major technology is developed, everything needs to be ensured that also it is cost efficient or mass technology available. But let's come to the ZFS Special Devices in detail. What is it? I'm going to explain it a little bit. First of all, I have to say I'm a sales guy, so I'm not 100% technician. Of course, I have some technical background, so I will try to explain it in a way that everybody can understand it. So first of all, we have to know ZFS, as the name already indicates, is a zettabyte file system. So it was designed originally to store large amount of data, like really large amounts. I think we have in Japanese, we have a customer with nearly 20 petabytes running some clusters. And this is like, of course, this is already a lot, but we have also here in Germany customers, we have big clusters like around 3, 4, even 5 petabytes running. And I would say this feature is not for users which are aiming for full-flash SSD or NVMe solution. It is mostly designed for big data environments, like when it comes to, let's say, 100 terabyte plus, there you could profit. So you can see already we have 3 different layers of accelerating the data. The first, I need to say, is write log, or also slog called in the ZFS jargon. The second is the read cache, or also L2R called. And then we added the special devices. This is a really expert tuning, which is really recommended that you're knowing what you're doing, because it can also suffer data loss if you're not knowing exactly what you're doing. But no worries here, our pre-sales guys, our experts can guide you through. all designing the systems as well. So it is called the special devices. It's kind of called a tiering because we store the metadata on it. So I have to explain, if you're using, let's say, iSCSI block storage with, let's say, a record size with 1 megabyte, and if 1 megabyte is written, then there will be a such called CFS checksum will be or a MD5 hash will be stored, and this is called metadata, like the addressing of the files, where it is stored exactly on the hard disks. And if you're using this metadata, it will be normally stored on the pool. But the pool consisting of hard disks, as said, in larger environments, is kind of slowing down then. Also, you could store some really, let's say, thumbnails if you have, like, say, a big music library or a big book library, and there's all these small text files, maybe, let's say, millions of text files. All these text files or stuff or metadata can be even then stored on additional devices like NVMe's only. So we also have this prioritization. That means like all these small records on that can be placed on these small devices, as already said. So what this brings is, this can bring a drastic performance improvement. So it is hard to say how it brings, because it is really dependent on what kind of data you're having, what kind of files you're having, and what else you're gonna run. Maybe you're running even deduplication as well. So it always has an impact, but so it's really hard to calculate this and measure it. We tested it, and we can say maybe in these environments we can expect maybe a 10 to 30% increase, but be careful with these numbers. These are really rough estimates here. So I think the best is I'm going to showcasing you this with the live demo we have prepared to there, and therefore I will showcase my screen here. Just give me a second. So we're going to share the whole screen. And then I'm going to swap directly into my demo environment. I'll see, I need to even log in. That is great. We prepared here a cluster demo environment. This is, by the way, of course, the official JovianDSS GUI, the graphical unit interface. In this case, it is even a cluster environment. As you can see, it is consisting of node A and node B. So here we have all this stuff here to manage. And here we could make a add cpool. Right now there is no cpool there. As we can see, we have all these unassigned disks. So it means local disk, means the server disk, which are on the server A inside. And then we can see also these remote disks, which are right on node B. So what we are doing here is we're focusing right now not on high availability. I will just showcase it with a single node here demonstration, because we want to focus on the ZFS special devices. So what I'm going to do here is, first I'm going to add a cpool, and then you can already see you don't have to do this. It's very easy. We got a wizard for it where it asks you to build the cpool of it. So in the past, there were this special devices group was of course not existent, and the deprecation group was also not existent. I will tell later about more. So what we can do here is we can select, for example, this is as an NVMe, as you can see here, and this is our just regular hard disks as SDB, SDC. I will just select them and then just build a pool out of it. So I already have selected 4 disks, and this would also already enable me to create, let's say, a RAID Z1. This is equivalent to a RAID 5, or even a RAID Z2, which is equivalent to a RAID 6, or it is a RAID 6. But I can, for showcasing, I can even select another disk. As we can see here, this is an SSD inside. This is also an SSD inside. It's a total mix. And therefore, I will select RAID Z3, which is also called, like, for triple parity, means 3 disks can fail at once, and we need at least 5 disks to build it. You would not build this for a cluster, basically, because it is not so space efficient. It would be highly recommended for, let's say, a backup or disaster recovery system. So we're just gonna add group, and then here we already have these data groups which we added, and this is fine. And then we're gonna select next. Now we are going to the write log. The write log is always recommended to mirror. And as you can see, the best here would be I could choose the NVMe, but I have just one NVMe. So it is not the best example here, because later on I'll also showcase how NVMe partitioning is going, but then I could also partition this NVMe. But also here, just remember, this is just one physical drive. It is always better to make it with two. So in this case here, I'm just like making a test. I will just select one SSD, and if I would add it, there is already a small warning showing up. And this is always because we should have as much redundancy as possible, of course, in this scenario. So it's what I'm doing is here. I'm just deleting it again, and I will just select these two SSDs, and these are for my write log, not special devices yet. I'm gonna add this group, and then I say next. I'm fine. The read cache, it's called ARC in the CFS. This would be the first layer here. I'm gonna skip now because it is not really needed for demonstration. So I'm gonna just say next. So now we're coming to the interesting part, to the special devices group. We have here the NVMe, and this is available here only for the NVMe. I will select this here, and we can already see it is not recommended. But I know what I'm doing here, so I can just say, okay, we're gonna do it. We're gonna face the risk and take it, and we will just add this group. So what happened here is, of course, again, there will be just a small warning, and as we're showcasing it here today. Okay, I'm going to select next. Now we're coming to the add deduplication group. In the past, or let's say we had, in general, I must say something about deduplication. In general, by design, we have deduplication off in our product. So you have to enable it by yourself, because we believe that most of our customers, let's say only 20, out from 20 customers, only maybe one is using it, because there need to be a lot of factors considered. So the first factor is, what kind of files do you have? The second is, you need a lot higher system requirements for it, because you need in general a lot of RAM, and therefore it is, we believe, it is only for experts here as well. What we can do here is, we can add a deduplication group. Means, in the past it was always that the deduplication table was always stored on the pool. But what can happen if the deduplication table is stored on the pool? It can happen, we experienced this even by ourselves, that we wanted to do a reboot with a system, and it took 8 full hours till the system was rebooted. Because in the beginning, there was the deduplication table, it needed to be written from the pool out of HDDs only, and this was extremely slow. And now we can add extra deduplication group here and select the NVMe as well. So it is kind of a special feature from the special device group as well. You can see it is a sub feature here, and this enables it that all this stuff will be stored on a fast NVMe as well, and it will enhance the performance tremendously. So in this case, I will just also skip it because I don't really need it here. I can just select next. This is like the same NVMe. And then we could also add some spare disk, but in this case, I don't need some spare disk here. And then I'm going to the configuration here. So I will just maybe name my tool webinar today, as we're doing the webinar. And then here we have some options as well, like auto trim. Everything, of course, is explained here. And then we can see here the small block policy settings. This is only when you use the special devices group. If you're not selecting any special devices group, of course, this setting will not be shown. And here is again some expert settings. How small should the block size be of this pool? So I will just select here, in this case, 4 kilobytes, because this is only for small file sizes. But again, I mentioned this is really for expert level. But as you can see, we have a lot of triggers or mechanisms built in the set pool wizard that you cannot do everything wrong. But in general, if this disks with the ZFS Special Devices fails, if you're just, for example, using one NVMe, we have a complete data loss of your whole pool. So now we're gonna click next again. Now we have our summary. And as you can see, there is again also the warning. And I'm sure if I'm creating the pool, there will be a warning again, which is okay in this case, because here I need to even confirm that I want to edit, because we're knowing what we're doing here. So now it takes a little bit time. All the metadata is written on the disks. So till the pool is created, afterwards, we're gonna showcase it where all the stuff is. So maybe let's use this time for a small coffee break. It should take maybe 10 seconds and then it will be done. All right, here we are. So what we can see here is we got this pool, the data pool. It's already online. Therefore, we see a warning, let's say, but that's only a yellow one. It's an unmanaged pool. This means nothing, that the pool is not high availability ready. And of course, we see here also that it is not safe. Yeah, because I was not building it safe. Now we can see how the pool is build it up, and when we can see here, we got the disk groups. In this case, the triple parity, a RAID set 3 called out of 5 disks, where 3 disks can fail at once. We even defined the write log here. That's what we did correctly with the mirror. And here we have the special device group. So therefore, I would really recommend in the device group at least a 2-way mirror. Even a 3-way mirror is mandatory, because if this special device group fails, you will suffer a complete data loss. So this is really important to know, because this is a expert setting again. So I think everything is clear here. We could do also some iSCSI targets now, but we're not doing it. What we're doing is now we're gonna delete the pool again, because we're gonna showcase later the NVMe partitioning. So what I'm doing is here, I need to confirm again, of course, that I want to delete it, and then I can delete it. Takes also a little bit time, but it goes much quicker than creating the whole pool. And then I will also swap back to my presentation. So right now we should be seeing it is deleted, and then I see all the unassigned disks again. So pretty standard. Everything I need to probably do a rescan, and then everything should be ready for it. So now all the disks are loaded up again, and then I'm ready for the next presentation. But first we're gonna talk about NVMe partitioning. So coming to the next point, NVMe partitioning. What it is and what we can do with here. So we believe this feature brings a lot. This is my personal highlight feature, because when it comes to system designing, we got a lot more options now. So NVMe partitioning brings nothing. If you already have an NVMe system already, then this feature is probably pretty useless. Some customers asked if we can add this for SSD. I'm not sure here about the development status. Maybe we can do it, or maybe we could already include it, because SSDs are still a lot of people believe that SSD is a good way to go. But now we're believing right now that NVMe is the best way of the usage. So what allows us NVMe partitioning? NVMe partitioning allows us that we can build different design, or like, let's say, even cluster design. And what this allows us, it is of course cost and hardware efficient, because we might less NVMe disk than we used before. And then we could also use the space better. As I already said, the write log here, it needs to be only very small. It means maybe 50 gigabyte is totally fine, but where can you buy an NVMe with 50 gigabyte? It is not possible. We had some Intel Optane with 100 gigabit, which was the excellent write log in my opinion, but this was a niche product and is not on the market anymore. So this allows us to define how big the write log really is, and that we use all the space what we have on the NVMe really efficient. So this is also the usage of it. It makes it really good. And of course, it gets simplified. We can use this, of course, also for the special devices, which I think is great, but as said, again, only for big data environments. So I'm gonna showcase this in the live demo. I'm gonna change my screen again here. Just a second. So Now I'm back to my demo environment, and here we can already see in this server we have only one NVMe inside. So as you can see on the SSD, we don't have this option. The SSD is the 200 GB one or this 200 GB ones. We don't have any option to make anything out of it. So what we're gonna need to do is here, first, we're gonna click this and then make partitions, non-data groups only. It means we can use this NVMe partitioning only for these cache devices, as said for the L2ARC, like the additional read cache, or for the slog file, or for the ZFS Special Devices. So in this case, we have around 120 GB, and what we need to do is we need to click Add Partition, and then we have this layer here, and then we can define, of course, how big the size is. In this case, I can, for example, say I want, let's say, 40 GB for my L2ARC, and then I'm gonna add it. And then maybe I want another 40 GB for my special devices. But remember, this is only one physical disk. You should use this with, of course, more NVMEs, more physical disks, and even to distribute the storage size better on it. All right, and then maybe I will say I want to make my write log with, let's say 30. In this case, add partitioning, and then I have some space left, and then we can already see how much is used here always. And then I could just use this, let's say in this case, I will just use 8 and then add it. And then there's some left. This is totally fine. This is maybe for even some metadata on the disk itself. This one I don't need. I don't need another one. And then what I'm gonna do is I'm gonna apply this. All right. So this takes, of course, a little bit time as well. And what we can see here now is I've got all these partitions, all these small partitions. Out of this 120 GB disks, we have all these smaller ones. And they cannot be used for any data disks. And as you can see, they're not blinkable. So the GUI is, of course, perfectly set up. As we can see here, it is right here. There we could make it blink, or we could also delete all the partitions. Again, if you're like, did a mistake, we have to start, all over again. What is important to know, you have to do this in the very beginning when building the pool. You cannot say you have already a pool in production and then you want to change all the sizes. It's not possible because it has to do with all the ZFS structures which are written beforehand, also kind of metadata. So what I can do is here now again, I could even make another C pool as we did before. Then I'm just using all these smaller ones. This time I'm making a RAID 6, I would say, or RAID set 2. I will add these data groups, which is totally fine. And then I'm going next. I will add a write log, and here I'm already able to make use out of these partitions. But as again, one physical disk, I have these 4 partitions. So I will say, for example, I will just use this. And here again, there will be probably a warning as it is not recommended, but we're knowing what we're doing. So we say add group. So we can see here, there's the warning already. So, and then I can make, go next to the next step. I can just select the read cache. I will say, okay, this 40 GB should be the read cache, is capable. I should get a warning here again, as it is not used here. And then I'm going next. Now we can select the special device group, and I'm gonna just select this one here, or I can select these 2 ones, and then I'm gonna add it. All right, perfect. Oh no, I already made a mistake, as we can see. See, this is even for the users like me. If you're doing some mistakes here, that is not possible because it is not usable. So I need to remove it and just select maybe a single one. In this case, let's select this one here and just add it as well. And then I should be fine. Now I could even add the duplication group where the duplication table is stored on. This is also not recommended in single, but I will just add it here. All right, perfect. Then I will go to the next step and also finish it. So we can see here again the size for the ZFS Special Devices, and I will just finish it And then I got my summary. As you can see, there's a lot of warnings showing up. So I did it not correct in the correct way, of course, because in this demo environment is also not really best option. But for showcasing it, I think it's really great. Now I need to confirm again that I'm knowing what I'm doing, that I created an unsafe pool, which is totally fine here. And then I'm gonna take a quick coffee break again. Oh, this pool we probably, oh yeah, this is just the name by design, pool 0. In this case, we did not name it webinar. And here we are fine, we are already online. The same warnings are showing up, and here I can expand it, select all the disk groups. In this case, we have a RAID 6. We can see the write logs, as said, not recommended here. We got the read cache. The read cache is fine, by the way, if it is one disk. So if there's, for example, a failover, the tiering needs to be started again. It is not failover possible by design in ZFS. Also have the special device group and also the duplication data groups. So everything is here seen. This is not maybe the correct sizing, but just for showcasing, I think it's totally fine. All right, I think we're done here. So we can maybe probably delete this pool again if we want to, or we can just go back straight to our presentation. In this case, I will just delete it and swap back to my presentation. So, what else is new? We have some other features implemented. I'm going to showcasing you here. The one is the Active Directory feature update, or also in the community called the support for RFC 2307 for Active Directory backend for Samba. It is some support configuration with the Unix user ID and the GID for the Unix, like through Microsoft Windows Domain Administrator. So it is especially for big domains and with different networks or different subnetworks, we can handle it now much better, and there's no conflict. So multiple trusted domain support is enabled here in this case. Because when we have really big customers and they have a really big Active Directory environment, like over 2 million users, and this needs to be handled really well. So all the things are possible here. And the next feature is SED. That means self-encrypting drives. Means we have drives which are on hardware side encrypted, and now we're gonna do it in the non-shared cluster, or also metro cluster called. In the previous, it was only working with the shared cluster model, but now it is also possible to do it in the metro cluster environment. The next feature I really like, because we got this macOS time machine support. In the past, previous users, or like when we did snapshots, like the users were always, it was always possible to select the snapshot from, let's say, previous versions over SMB. And now this is also possible for the Mac OS X users here. Also, it is some time machine support. This is like a lot of stuff to read. You can also Google it, what time machine really does. But in general, we are gonna supporting this as well. Yeah, what is coming up next? In the next releases, we would like to encourage you here. We're doing a survey, and we're going to post it right now in the chat, or also later on. We have this survey where we would like to encourage you to fill it out, because we're a small software development company, and we're taking care what you guys, what the community is saying, or what our partners or even technology partners are saying, what is important, what kind of features are important, and we would like to fill it out. And because this will also affect how we develop the software, maybe we will prioritize some features over another and see what the market is needed, or where's the demand for the current market. So we believe this is pretty useful for everybody, so that everybody can profit in this way. All right. Next step is the DSS V7 end of life. This is a pretty big topic. As I already talked in the beginning, we were doing the end of life announcement, but as you can see, we have the official date is the November 1st. It is the time where everything is like, well, not going down, but we still, of course, supporting the product for the next 5 years over it. And you can, of course, still purchase all the support. But this has to be done till November 31 in this year. And if you want to do it, you can do it. But of course, we would like to we would like to encourage you that you're migrating to JovianDSS, that just to make use out of the ZFS technology. DSS V7 was based on XFS file system, where we had a lot of limitations, and we also had some cluster features not added. And of course, the most important part was all the snapshots was not really possible, because we believe, or what people might not understand correctly, that our product is not just a storage software by itself. It is backup disastery and also business continuity. This is really important here. Of course, we're gonna have questions and QA later on for this. There's maybe a lot of questions from our customers coming up. We already made some Q&A. We already, by the way, posted some posts in our channels. You can also see a migration guide on our website if you're not knowing how to migrate the best way. Also, our pre-sales team will be there to guide you through the whole process, and we can do even individual offers here, but this is here on the next slide. So, of course, we have a slightly different licensing model here for JovianDSS, and for every customer which is coming from V7, we're individually open to talk to them and plan for them what is needed. Because a lot of customers, they have still some really good old powerful V7 hardware, and they're like thinking maybe, how can I utilize this hardware, or how can I saturate it? And for example, it can be used as a backup or even disaster recovery system, or maybe the configuration just needs to be slightly changed. We have to say in DSS V7 was more a hardware rate design product, but in CFS, we follow the way that we say HBA is the first choice. We still support hardware rate and CFS, but in most cases, HBA is the better choice. We also have a blog article, and in some scenarios, it makes sense that a hardware rate might be the better choice, for example, in metro clusters or non-shared HA clusters, like with really big datas. Like I would say maybe 500 terabytes onwards, it makes maybe sense to use a hardware rate controller in this case, just that we're not losing so much disk space. Yeah, what we're offering here as well is some upgrade support. So maybe customers from V7 which still have remaining support, this can be talked individual that we may be transferred to Jovian. This is possible. And also that we're planning, this is the most important part, together with our pre-sales, with our experts, that we're just checking is everything compatible and so on. By the way, we can still also already say for DSS V7, we will also release a next update. It will come soon, probably in the next month or the next 2-3 months. I'm not sure here about correct thing. It will be up 75. But there we are not gonna focusing on any new features in DSS V7. It is only for the maintenance, like for new drivers or security fixes. So the best idea would be, of course, to contact us here, and then we're gonna find the best individual solution for you. On the next slide, I would like to encourage you to visit us on the CloudFest, because we will be there. Here in this picture, you can see myself and our CIO Christoph and my sales colleague Patrick. This time, Christoph will be not there. Janusz, our Chief Technical Officer, will be there, and we're gonna showcasing a demo system, of course, live together with our tech partner Toshiba, because we're working very closely with them together since many years. And if you want to have a coffee break with us, every time you're welcome. If you want to have a nice chat in person, you're really welcome. A lot of customers visiting us. This is a really international event nowadays. It is based in Germany, in Europa Park Rust. So if you like to join us, we would like really to welcome you. Yeah, last but not least, we want to say a big thank you to all our partners, to all our TechMart partners. We're working here together. Of course, we're working most closely with hard disk or SSD manufacturer vendors such as Toshiba or Seagate, but also, of course, Western Digital, Kioxia, Intel. All the technology partners are needed because we, of course, testing all the hardware and everything that everything runs smoothly. We have a HCL list on the website, which you can check out, and for every part which you might having issues or which you might suspect is maybe not working, we can check this out as well. And even if you're super unsure about it, you can also contact our pre-sales guy. They will check the PCI ID if this spare part is used. For example, we had recently a case where a QLogic fiber channel driver was not really supported because it was a HPE branded QLogic, but we could see only one small letter made a difference because it was a Emulex card, and we are not officially supporting Emulex when it comes to fiber channel. Of course, we support QLogic here, but this made a big difference. So this was like an OEM branded product, and therefore this is really good that you contact us and work with us together. Yeah, the next part will be the Q&A session where I'm gonna try to answer all the questions as best as I can. As said, I'm kind of limited technical. I have small background here, but I will try my best here really. And if not, I will of course forward all these questions to our pre-sales team, which will take care and coming back to you SAP. So I would like to thank you for joining us in this webinar. And now we're like open for all the questions. So right now I'm seeing in the chat is pretty empty yet, but I'm gonna wait myself a little bit here, maybe take a small coffee break as well, and maybe wait for some questions. Maybe I was a little bit too quick showcasing everything and now you're not having any questions. So I'm gonna wait still a little bit because I can see somebody's maybe typing here. Some thank you as well here to Mr. Eberstobler. And yes, to say thank you as well. So we can see already, Sven Meyerhofer asked, NVMe partitioning, that means read and write cache and special devices. They could be with 2 NVMe's. Yes, that's correct. This is possible now. We can do this with 1 NVMe, let's say less. But you have to keep in mind, of course, these special devices, you really need to know what you're doing here, because if these fail, then we have a complete data loss. But yes, it is possible. Basically, we could design a cluster with 1 NVMe less. In the past, I was always recommending, for example, a HDD system with 3 NVMe's, 2 dedicated for the write log and 1 for the L2 ARC. But now we can just save one and use some space out of it for the write log itself, for the ZFS Special Devices, and for the read cache. So I don't want to make anybody afraid here. So it is really good here. It is, yeah, how I should say. It's a very powerful feature, but be careful with it. So we got some German question. Yeah, we have some practice here about how the size should be distributed from the write cache, also the read cache and the special devices. Exactly. The write log doesn't need to be that big. That's true. Theoretically, this can be also calculated. I'm not exactly knowing how this calculated, but 50 gigabit is enough for everything, for every environment. And therefore it is totally fine. But what I would recommend is better ask our pre-sales team here as well. They can exactly calculate, even if you're using a 10 gigabit NIC, a 25, a 50, or even 100 or even 200 gigabit Ethernet, even with RDMA, how much the size of the write loop should be. And of course, all the other stuff, yeah. It is also, of course, dependent how the pool size is. So there is a lot of factors to consider. and also what kind of files are stored. So in ZFS in general, I have to say, the better we are planning the system, the better the successor laters will be on laters. But it is really complicated, at least from my point of view, because I experience these special devices with a lot of complexity, but I'm no technician here, so this is fine. So, are there any plans for a CFS-based successor of DSS v7? Yeah, maybe. I would say stay tuned in. We are maybe planning something, so it will be still interesting. We are planning definitely maybe some products, but this can be only discussed with our closest partners when we have an NDA, and then we can talk openly about it. I cannot say this official in the webinar, to be honest. So maybe we got some other questions here. I'm gonna take a look here, maybe that I'm overseeing here something. So, is there a recommendation for the special devices for the same redundancy level for the data groups? Yes, the special devices should be at least two-way mirror, better three-way mirror, and best would be even four-way mirror. But it is always a question how the system is designed. Yeah, maybe there is like a cost factor inside, which is not allowing us to use that much NVMe's. But if we're having, let's say, really big data environments, I'm talking about, let's say, 1 petabyte pool, then I'm sure like there is extra NVMe's available, which should be used then to accelerate the data. And it's really dependent how much small data there is, how much metadata there is. We can even outsource all these small, let's say, very small text files on these NVMe's. And we can even add laters on NVMe's towards it, but we cannot remove it. And if they're running full, I think these will be stored again on the pool. But this is without 100% knowledge here of me. That's what I understood. So I hope I got this question covered. Special devices of SAS SSDs. Yeah, I think I told already something about it in the beginning. Some people asked us to do this functionality. I'm not sure exactly how fast the SSD is compared to NVMe. I think it is probably possible. I think from a technical point of view, it should be possible and it probably makes sense. I'm not sure exactly why we decided only to use it for NVMe in the first stage, but I see it as very useful because SAS or SATA SSDs are still the way to go, I would say. And from my perspective, it makes sense, but maybe the development has some other opinions about it here. I will definitely cover this question and to answer it. I think we even received it once, but I can't remember the answer. But I will make sure you get, of course, a detailed answer on this, dear Rainer. All right. Do we have some next questions? I think probably not. So we still have some time here. I'm still here till 12 o'clock and then I'm leaving. No, I'm just kidding. So maybe drink some more coffee. All right, Thomas, then thank you very much too. I think here at this stage probably we can end it, but we will still wait a little bit and see if there's still some question coming. Please, everybody which has questions, even afterwards, send us your questions even directly to my address or directly to Open-E, to the pre-sales. You can see here, this is my email address if you would like to. By the way, this presentation will be shared later on as PDF as well, so you can see and learn something maybe out of it and check it once again. And yeah, our pre-sales will take care and handle all the questions. Yeah, and therefore I would like to say thank you everybody for tuning in. Good. I think then we are fine here. Then we can probably finish this webinar. I would like to say thank you for all this interest. And as said, get in touch with us, visit us at CloudFest, drink some coffee with us, have some fun with us. We would really like to encourage you here, therefore. Thank you very much. Have a nice day and maybe see you soon.